All right, so here's our 1 hour side quest to make LiBCM control the PDU fan, which is what cools the IGBT driver. We're gonna start zoomed in here. I'm gonna show you what I've actually done, and then we'll zoom out and actually show what happens. So all I've done is I've made 2 connections. This is a proof of concept, but it's also basically a finished product. And this is going to be, these parts are gonna be included with the Fomaco kits, and we'll talk more about those details in a minute. So the first thing that I've done, and of course there will be a better video with the actual Fomaco installation stuff. So this is just kind of a proof of concept for now. But the first thing we're doing is there are 2 relays on the junction board here. These control the OEM battery fan, which on Fomaco we're no longer using, and also which LiBCM can control. So due to the power and beauty of open drain logic, we are going to tap toward both the MCM and LiBCM can control the PDU fan safely. There's no issue. So the MCM can request it when the car is on, and LiBCM can also request it whenever it wants. So what we've done is we've tapped in, I have these little posi taps, and we have tapped into the yellow black wire on this connector right here. And so the yellow black wire goes to this position on the rear relay. So if you have the rear relay, which is how it's installed in the car, you want this tap. This is just a spade tap, and I've literally just stuck it in to that position. Again, it's this position on the rear relay. The front relay here is actually rotated, so instead of being like that, it's like this, and we're going to hook to that position on the front relay, which again is just a spade terminal, and I've just crammed it in here like that. And then so the rear one hooks up to yellow black, and the front one hooks up to the white wire on this gray connector. Now I will point out, and this is be very careful here, there are 2 white wires. Honda often puts same colored wires in the same connectors that do different things. It's the silliest thing ever. There's so many colored wires in here that they would reuse it. You don't want the one on the driver's side. You want the one on the passenger side here. The 2 wires you're hooking up to are yellow, black, and white, and they're both next to these chassis ground blacks here. So don't hook up to the wrong white. You don't want to do that. Anyway, yeah, I'm using these posi tap connectors. They will be included with the Fomaco kit because this is something you'll probably want to keep your MPU cool. So with this, I'm going to reconfigure the camera here so that we can kind of see the whole thing going on. And as I say often on these proof of concept videos, you know, I worked on this for like maybe an hour while on the phone with someone else. So what I'm saying is that the production quality on these videos is not great. It doesn't have to be great. I'm just showing a proof of concept. So you get to deal with me zooming out, changing the ISO, etc. No cuts. All right, so let's drop that ISO way down. Perfect, cool. All right, so now that we've got those 2 connections made, oh, I need to plug the power in because the battery's dead. All right, excellent, now we're charging. Cool, so now, right now, just in the code, I've added some test cases. So right now the fan is off. We can do test 2, we'll turn the fan to low speed. So now the fan's on low speed. I don't know if you can hear that here, but you can certainly hear it under the car. So I'm gonna hop under the car here. This is the position A that I'll go to. So that's the low speed. And then we can go test 2, 3, I think. Yeah, that's high speed. So here's high, and here we're back in position A. Position A is basically underneath the car by the passenger rear bumper. And then of course we can go ahead and turn it back off. Test 1. So notice that we're doing this while the car is off, which is kind of cool. Now, unfortunately, the PDU fan is powered by the 12-volt battery, and LiBCM cannot connect to that 12-volt battery. It can't turn the DC-DC converter on when the car is off, etc. So even though LiBCM can control this fan when the car's off, it probably won't because it would kill your 12-volt battery. So yeah, anyway, there's that. But yeah, no, pretty fun. Now, the second part here I wanted to talk about is a future derivative product that I have not designed yet. and am not going to do right now, it's too much of a distraction, is basically getting rid of all of this junk in here. These 4 relays are completely worthless. There's no reason they should be in there. I don't know if you can see those in frame. I gotta check over here, see if you can see them. Yep, you can see them, excellent. These 4 relays are totally worthless. 2 of them control this MPU fan. That's what this hack we're doing here does, is it controls these 2 relays, low and high speed. This is ignition hold, that is the contactor. All of this can be solid state. And you know, it's like, oh, why would you waste the time with that? It's not really a relay. I hate relays, so I've mentioned it before, but I used to work in support at National Instruments, and for, I don't know, a year, my only job was product support for relay modules. Some of them had hundreds and then even thousands of relays on them. I hate relays after having supported them because they break. They are a mechanical failure point. Anyway, I never use relays on anything ever, period. I always do solid state everything. When I see relays in a product, this is just a tangent at this point, it makes me know that the designer is a newer designer, or in the automotive cases, a traditional designer is a nicer way to put it. Anyway, these are completely useless. You don't need them. These can be solid state. But again, that's not the main issue here. I wouldn't design a product just for that. The main issue is that this MPU fan is an 8-volt fan. And to run it at 12 volts, you basically have to sink 4 volts times whatever your current is in power across these resistors. So these 3 resistors here are literally just absorbing the voltage delta based on your whatever your low speed, high speed is. So when you are at low speed, this is data I gathered today. When you're at low speed, the fan only has 5.5 volts across it, whereas the 12-volt battery is at 14.3 volts. So in both cases, it's 14.3 volts. At low speed, it's 5.5 volts, which means that, 9 volts, around 9 volts of your 14 volts is literally just sunk as heat across these resistors, all 3 of these resistors in low speed. And that is just beyond silly, because that means that we are sinking around 9 volts times 2.5, so 18, 24, 25 watts as waste heat on something you're trying to cool. So you're trying to cool this IMA bay and this PDU unit, and then you're like, hey, let's dump another 25 watts in here. Now, granted, this IGBT driver is sourcing 22, 23 kilowatts, and it might have 500, 1,000 watts across it, so what's another 25 watts among friends here? But it's just silly. This is a terrible design. This is an intern design here. This was terrible in 2000, and it's terrible now. So at high speed, we have 8.4 volts across this fan, which is its operating voltage, its max operating voltage, and it's pulling 4.7 amps. So even in this case, we have 4.7 amps, and so the voltage is a little higher. At this point, it's 14.3, 8.4. It's about 6 volts times 5 amps around, so it's maybe 28 watts. So it's about the same, actually, amount of power whether the fan is on low or high speed. And that is, again, it's just beyond silly, because in low speed, you're wasting more power here than you are actually giving power to this fan. And in high speed, it's the same power, and the fan is getting more power at this point, but it's still, you basically have 25 to 30 watts of stupid heat in here that just doesn't need to be in here. So what you could do to replace this is, and this is a product, I am not going to work on it right now, but it's just something that I'm going to put in the quiver, and then someday if I'm bored, I'll do this. This is a very simple project. In fact, if someone else wants to do it, be my guest and do it. But basically, the goal here is you take these 4 relays out, and then you put in a PCB that has spade terminals on the bottom, and it basically can tap into all of these signals here, and you can basically replace 2 of these relays, the ignition hold and a contactor, with high side drivers. Solid state. I'm using it on the LI control, so if you look at the open source LI control schematic, you could literally just copy paste that here twice, 1, 2, and that would give you the ignition hold and contactor relay. Cool, now that's solid state. And then 3, 4, this fan, this would just be PWM. So you would get rid of these resistors entirely, and you would take whichever one of these 8,000 red spade terminals on these resistors. There's only 6 of them, but whichever one of it is that actually goes to the fan here, I don't know. It's one of these 6. It's definitely not these 2. It's 1, 2. I don't know. It's one of those. Anyway, you would, in fact, it's probably actually one of these 2. But you would take this off, and it would plug into whatever circuit board you made here, and it could actually sneak through the little hole right here. So you'd unplug that. You'd remove all 3 of these resistors, and this, I don't know, this would just go away. And then this could be a completely solid state thing, and instead of, you'd still be putting 8 volts here, but you would basically do pulse width modulation on this. So you'd have an open drain FET, and you would pulse width modulate the output of this, and you could pulse width modulate it to any voltage you wanted, 2 volts, 4 volts. So this could be a variable speed fan. Maybe I'll do that eventually, maybe not, we'll see. But going back to what this proof of concept is, the 2-wire solution here that was added in 10 minutes or whatever, this will be what is shipping with FOMOCO, so that the MPU module will run at low speed when the key is on and high speed at higher loads. Probably what I'll do is actually have some kind of power integrator where LiBCM basically says, maybe it could look at the temperatures of stuff. But anyway, LiBCM doesn't have access to these temperatures. At least I don't think that it does. I think the MCM only tells LiBCM what the MPU fan states are on METSI. I don't think it actually tells the IGBT driver or DC-DC converter's temp. Now we could tap into those because they are also in this blue harness. That's getting a little more complicated, and I don't think that's going to be the solution. But I think that the solution will just be that LiBCM knows how much current that is pushing through this IGBT stage, because we are reading the battery current sensor, and we could basically just integrate that and say, hey, if we've used more than on average 1,000 watts or 10,000 watts over the last minute, we'll do low speed, and if we've used on average more than 15,000 watts, we'll do high speed or whatever. That's all firmware stuff at that point. So anyway, this is the recommendation I have now. I had previously written some other stuff about tapping this black yellow wire. This is what I had written previously today on this thread. You can basically tap that into here and achieve a similar goal, except that now LiBCM can't control it. You're still dependent on the MCM to control this fan. Now I did say it earlier, but remember that the MCM can still control this fan as well. So if for some reason LiBCM is not controlling the fan and this gets hot, we haven't changed the functionality. The MCM can still drive that. There's no issue there at all. Anyway, thanks for watching. This is just a very, very fun side quest that seems to work pretty well. I will get the firmware to control this for FOMOCO in there ASAP, and that'll just be a .rev in the pre-release branch. And I'll post a link to that when that happens. I'll probably do that tonight because honestly, now that I have it in the car and it's working, I'm gonna just leave it because I like it. And of course I want it running on my firmware. So yeah, this should be added shortly. As always, thanks for watching.